You have seen fire before, maybe in a small kitchen flame, dancing quietly under a pot. Maybe in a campfire where orange light flickers against the night. Fire is something you understand. It burns, it glows, it fades, it feels controlled. Even a volcano on Earth, as terrifying as it is, still belongs to this world. You can stand far away and watch it. You can measure it. You can name it. Lava flows, ash clouds rise, and eventually, it stops. Earth feels stable. But now, imagine a place where the ground itself cannot stop burning, where the surface is constantly tearing open, where entire landscapes are reshaped in days, not centuries. A place where volcanoes do not erupt once, but all the time. You are no longer on Earth. You are standing on Io. Io is one of the many moons orbiting Jupiter, the largest planet in our solar system. From a distance, it looks almost beautiful. Yellow, orange, and black patterns spread across its surface like paint on a canvas. But that beauty hides something violent. Io is the most volcanically active world ever discovered, not just in our solar system, in any world we have observed. On Earth, there are about 1,500 active volcanoes. That sounds like a lot, but on Io, there are over 400 active volcanoes packed into a world much smaller than Earth. And they do not rest. They never rest. Some of these volcanoes erupt lava fountains that rise hundreds of kilometers into space. Imagine a volcano so powerful that its eruption could stretch from London to Paris and keep going. And it does not happen once. It happens again and again. And the surface of Io is so active that scientists believe it is completely reshaped in just a few million years. On a cosmic scale, that is nothing. It means Io never gets the chance to become old. It is always new, always burning, always changing. If you could stand there, if you could somehow survive, you would see rivers of molten rock glowing brighter than anything on Earth. You would see the ground crack open beneath you. You would hear nothing, because there is no air, no wind, no sound, just fire and silence. Io orbits Jupiter at a distance of about 421,000 kilometers. That might sound far, but in space, it is incredibly close. So close that Jupiter's gravity pulls on Io constantly, stretching it, squeezing it, and twisting it. This is not gentle. It is violent. And it is the reason Io is the way it is. And the moon is being torn apart, slowly, endlessly, by the largest planet in our solar system. Every orbit, Io is bent and compressed. Its interior heats up, not from sunlight, but from this constant stress. It is like bending a metal wire back and forth until it glows. Except the wire is a moon, and it never breaks. The heat builds, the pressure rises, and eventually the surface cannot hold it anymore, so it erupts, again and again and again. From space, telescopes and spacecraft have captured images of Io that do not look real. Giant plumes rising like ghosts, lava lakes glowing like open wounds, entire regions covered in fresh flows that did not exist just years before. These are not rare events. This is normal. This is everyday life on Io. And yet, as extreme as this world is, it is still part of our solar system. It is not distant. It is not hidden in another galaxy. It is right here, orbiting a planet you can see with your own eyes from Earth, a small point of light in the night sky. And that raises a quiet, unsettling thought. If something this violent can exist so close to us, what else is out there, waiting in the dark? You start on Earth. Solid ground beneath your feet, a sky above you that feels endless, but is actually just a thin layer of gas hugging the planet. The deepest hole humans have ever drilled, the Kola Super Deep borehole, reaches about 12 kilometers down. That sounds deep, but Earth's radius is over 6,300 kilometers. We have barely scratched the surface. Even our greatest efforts do not come close to reaching the center. Now imagine taking all of Earth's volcanoes, all the pressure, all the heat, and compressing that activity into a world about the size of our moon. That is Io. Io's diameter is about 3,643 kilometers, smaller than Earth, smaller than Mars. Yet its internal heat output is more than twice that of Earth. Twice. This is not because Io is bigger, it is because Io is being pulled apart. Jupiter's gravity is so strong that it creates something called tidal heating. As Io orbits, it is constantly stretched into a slightly oval shape, then released, then stretched again. This flexing generates enormous friction inside the moon. Friction becomes heat. Heat becomes magma. Magma becomes eruption. On Earth, most volcanoes are powered by radioactive decay and leftover heat from the planet's formation. On Io, the energy comes from motion itself, from being trapped in Jupiter's grip. But Jupiter is not acting alone. Io is also locked in a gravitational dance with two other moons, Europa and Ganymede. Their combined pull keeps Io's orbit slightly uneven, ensuring that the tidal forces never settle down. It is a system that feeds on itself, and Io pays the price. Every orbit takes about 1.8 Earth days. In that short time, the entire moon is flexed, heated, and stressed again, over and over. There is no relief. Now consider one of Io's largest volcanic features, Loki Patera. It is not a mountain, it is a massive lava lake, about 200 kilometers across. That is larger than many cities on Earth. Imagine an entire region, bigger than Los Angeles, filled with molten rock, glowing and shifting. The surface of this lava lake is thought to crust over, cool slightly, then sink back down, exposing fresh magma below. It is like watching the surface of a boiling ocean. But this ocean is fire, and it is happening in silence, because Io has almost no atmosphere. The pressure is so low that any gas released by eruptions escapes quickly into space. There is no thick sky to carry sound, no air to scatter light. The surface is exposed, raw, unprotected. Temperatures near active lava flows can exceed 1,600 degrees Celsius. That is hotter than most lava on Earth. Hot enough to melt not just rock, but even some types of metal. And yet, just a short distance away, temperatures can drop to minus 130 degrees Celsius. Extreme heat, extreme cold, side by side. This is not a balanced world. This is chaos. And then there are the plumes. Some volcanic eruptions on Io send material up to 500 kilometers above the surface. To understand that, let's consider this. The International Space Station orbits Earth at about 400 kilometers. Io's volcanoes can shoot material higher than that, higher than human spaceflight, higher than the edge of space as we define it on Earth. These plumes spread out and fall back down, coating the surface in sulfur and sulfur dioxide. That is what gives Io its strange yellow and orange colors. Not sand, not soil, sulfur. The same substance you might recognize by its sharp, choking smell. But on Io, you would not smell it. You would not smell anything, because there is nothing to breathe. Now step back. Look at Jupiter. Jupiter is so large that more than 1,300 Earths could fit inside it. Its gravity dominates everything around it. Io is just one of its many moons, caught in this immense gravitational field. From Io's surface, Jupiter would fill a huge portion of the sky. It would not look like a distant planet. It would feel like a wall, a giant striped presence hanging above you. and it would not stay still. As Io orbits, Jupiter shifts in the sky, looming, massive, unavoidable. You would always feel it there, always. And here is the gut punch. All of this, the constant eruptions, the burning surface, the violent forces, it is not rare in the universe. Io is extreme, yes, but the processes shaping it are common. Gravity, motion, heat. These are basic rules, which means there may be countless worlds out there, just as violent, just as unstable, just as indifferent to anything we would call life. Io is not special because it is unique. It is special because we can see it, because it is close enough for us to witness what these forces can do, and we have only just begun to understand it. Spacecraft like Voyager, Galileo, and more recently Juno have sent back images that feel almost unreal. Bright eruptions frozen in time, shadows cast by plumes, patterns on the surface that change between observations. You are looking at a world that refuses to stay the same, a world that is alive in the most destructive way possible. And yet, even as we capture these images, even as we measure temperatures and map volcanoes, there is something we cannot fully grasp. What it would feel like to be there, to stand on a surface that is never truly solid, to watch the ground open, to see fire rise into a black sky with no sound to accompany it, to know that beneath your feet, the entire moon is being twisted by forces you cannot see and cannot escape. Because Io is not just a place, it is a process, an ongoing act of destruction driven by gravity itself. And if gravity alone can create something this extreme, what happens when you go even bigger? Now pull back. Leave Io behind. Leave Jupiter with its immense gravity and its many moons locked in silent motion. Move outward, past the familiar planets, past the orbit of Neptune, into the wider darkness of space. Io becomes a dot. Then it disappears. And yet, what you saw there does not vanish. The forces that shape Io, gravity, motion, heat, exist everywhere. They are not special to one moon or one planet. They are part of the structure of the universe itself, which means the violence of Io is not an exception. It is a rule. Across the galaxy, there are worlds being stretched, crushed, and heated by their stars and by each other. Planets that orbit so close to their stars that their surfaces melt. Moons that are torn apart by tidal forces. Systems where stability never had a chance to exist. We just happen to live in a place that is calmer, for now. Earth feels stable because on human timescales, it is. Continents shift slowly. Volcanoes erupt occasionally. The sky changes, but not in ways that threaten everything at once. It feels safe. But that sense of safety is local, temporary. Because when you look at Io, you are not just seeing a distant moon. You are seeing what happens when the balance shifts, when gravity and motion align in a way that does not allow for stillness, and it makes you realize something uncomfortable. The universe does not aim for comfort. It does not aim for life. It does not adjust itself to fit human needs or expectations. It follows its laws, simple, consistent, indifferent. And sometimes those laws create something beautiful. And sometimes they create something like Io, a world that burns without end, a world where the ground is never at rest, a world where the idea of standing still does not exist. And yet, from millions of kilometers away, we watch it, we study it, we turn its chaos into data, into images, into understanding. That is what makes this strange. Not Io itself, but us. Because in a universe filled with places like this, where stability is fragile and violence is common, there exists at least one world where beings can look up, notice, and ask questions. You, standing on Earth under a calm sky, thinking about a moon that is tearing itself apart in silence. There is a distance between you and Io that feels enormous, hundreds of millions of kilometers, a gap so vast that it seems impossible to bridge. But through observation, through science, through curiosity, you close that gap. You see it. You understand it, at least a little. And in doing so, you change what it means to be here. Because the more you learn about places like Io, the more you realize how narrow the conditions for your own existence are, how specific, how unlikely. A stable orbit, a protective atmosphere, a magnetic field, liquid water. None of these are guaranteed. They are circumstances, and they can change. Io reminds you of that, not by speaking, not by signaling, but by existing exactly as it does, loud in its violence, silent in its presence. A reminder that the universe is not built around you. You are a small part of it. A brief moment on a planet that, compared to Io, feels impossibly gentle. And as you look up at the night sky, at the faint point of light that is Jupiter, you might not see Io at all. It is too small, too distant, hidden in the brightness of the planet it orbits. But it is there, burning, breaking, reforming, over and over again, unseen, unheard, and completely real. And the next time you see a flame, small, controlled, familiar, you might remember that somewhere out there, fire does not behave the way you expect. It does not wait. It does not stop. It simply continues in silence.